And then we loaded a year of data. This consisted of maintenance plans, notification, work orders, status changes, and we also took sensor data and sensor data specifically for a number of critical pieces of equipment. And we brought all of that together in a process mining solution, which was then used to actually analyze, okay, what is really happening? Where do we have the issues? Why are these issues occurring? And next to that, we use machine learning models. These were Python scripts that we would run over the data to make better predictions of failure rates, for example, by analyzing the sensor data and the orders that came through. Really identify where are our maintenance plans working and where do we think they can be improved. We used all of that input to develop a plan together with the client to find out, okay, what are the quick wins and what are longer term improvement actions. I've got a couple of screenshots. These are from a demo solution which is based on that use case. So we had a maintenance process flow that you see here presented on the left, and on the right side is a picture that actually shows timing. These are not representative of your real data set, but it gives you an idea of what we looked at. So we looked at, okay, how long are these steps taking? How many days on average, medium? Why is that happening? Do we see outliers? And what is it we can do about that? Then we had a number of different dashboards, so dashboards to track those KPIs and also perform further root cause analysis. And often we combine that where we might say, okay, let's look at the critical incidents, then look at the process flow, then look at the particular sites if we see differences. And what you see on the bottom right in the second screenshot is the pieces of equipment and how many work orders we have related to that equipment and what the costs were involved. So to really make it tangible and pull out the specific examples. After doing all this work, there were quite a few benefits. So we identified a number of hidden patterns leading to equipment failures that weren't that well known to the client. As mentioned, we used those machine learning models to better forecast where there might be issues in the future. We were able to apply proactive interventions. And we improved a number of maintenance plans to just better align with what is really relevant. Because obviously, if there's things that are perhaps less key to perform that maintenance, considering the risk involved, then that might be a decision to be made. We improved the asset utilization. We fixed a number of bottlenecks and rework activities, and overall, reduced the cost of their maintenance process. And a nice thing that we also achieved was actually better safety, because we had now good visibility into how, what the technicians are doing and what technicians got assigned to which tasks. And based on that, we could identify things like, okay, this is overwork, or we've got the wrong person to do this kind of work. And with that, we also were able to improve our compliance and reporting in this space. That covers our predictive maintenance use case.